Okay, here we're looking at the discriminant of a quadratic function. Okay, so it's a new terminology for us, but it's quite easy. So you can read through this text, but the quantity b squared take 4ac from the quadratic formula, that's what we call the discriminant. So we use the symbol delta, which comes from the Greek alphabet, which is just a triangle to show the discriminant. Delta is equal to b squared take 4ac, and that b squared take 4ac just comes straight from the quadratic formula. So another way of writing the quadratic formula is with the triangle inside the square root instead of the b squared take 4ac. So what the discriminant tells us is quite interesting. We have 4 dot points here. If the discriminant is greater than 0, then the square root of delta is a positive real number. Okay, that makes sense. Basically, this is saying if we have a positive number, a number that's greater than 0 is a positive number. So if delta is a positive number, there are 2 distinct real roots. Okay, so if we have the square root of 5, actually let's say the square root of 9, okay, this could be either plus 3 or minus 3. Okay, so the square root of 9 we often write as plus or minus 3. So what this is saying is if the number is positive, then it's going to have 2 roots. And what that means graphically in terms of a quadratic equation is that 2 of these are real numbers. Okay, so probably in the past this has been the most common case. Now we're starting to look when things are a bit different. Okay, so say for example the discriminant is equal to 0. All right, if the discriminant is equal to 0, then that means these solutions here, okay, when we're solving a quadratic equation, these will often be our solutions if we're using quadratic formula. But because the discriminant 0, we're taking away 0 and we're adding 0, then the only solution, as is highlighted here, is minus b on 2a. And we notice that that is also the equation of the maximum and minimum point of a quadratic function. So what's that going to look like graphically? Like this, okay? It touches the x-axis at the minimum point and then goes up. So we call this, we say it has only one solution, or we call it a repeated or double root, whichever you prefer. Okay, now in the last circumstance, just draw an arrow. In the last circumstance, that's relevant. The very last one I'll discuss as well. But we have if delta is less than 0, there are no real roots. Okay, and what that means, if delta is less than 0, that means we've got the square root of a negative number. Let's say negative 5. Okay, and it's impossible to have the square root of a negative number. And if you go on to study further mathematics, you start to learn about imaginary numbers. But that's not relevant for us. Okay. However, that can be expressed graphically. It just means the function does not have real roots. Okay. So, for instance, that might be a quadratic that looks like this. Okay. The roots are where it crosses the x-axis or makes y equal to 0, and this function simply does not do that. Okay. So, if the function has no real roots, this is what it's going to look like graphically. And the very last one's just saying if a, b, and c are rational. Rational just means that they can be expressed as a fraction, and delta is a square. Okay, now this word square for delta just means that either delta is going to be 4, 9, 16, 25. Okay, you start to notice a pattern about these are square numbers. Okay, that's 2 squared, 3 squared, 4 squared, 5 squared. So if delta is a square, then the equation has rational roots. All right, which means basically it's just saying they're going to be nice, pretty numbers that you can find by factorizing the quadratic equation. So let's have a look at a question. We have the equation x squared take 7x plus 9 equals 0. Question A, find the discriminant. Okay, well we know that delta is equal to b squared take 4ac. And we're dealing with a traditional quadratic equation here. So we have a, b, and c. So all we're doing is putting those values into the equation. So b is -7. So we have -7 squared. Take 4 times a is 1 and c is 9. So let's calculate this. -7 squared is 49. Take away 4 times 1 is 4 times 9 is 36. So we have 49 take 36. This is equal to 13. Okay. Now, 13, which piece of information? Okay, so we found the discriminant. That's part A done. The discriminant is 13. So part B says, hence, state the nature of the roots of the equation. So that's where we're going up here to the information we've got up here and saying, okay, is delta greater than 0, equal to 0, or less than 0? Well, the answer is 13. 13 is greater than 0. So we say the square root of delta is a positive real number, and there are two distinct real roots, okay? And these are these two values here, okay? Part C says check your answer by solving the equation. So what that means is we're actually going to use the quadratic formula now. Now here we've already solved delta, so we don't need to solve the part inside the brackets. So normally quadratic formula is x equals minus b plus or minus the square root of b squared take 4ac on 2a. Now we've already solved this part, okay? So we're just going to put the 13 in there and carry on like we normally would. So x is equal to, now b is -7, but it's -7, so it's going to be +7, plus or minus the square root of 13 on 2 times 1, which is just 2. Okay, which means we can't factorize this any further. Okay, particularly when we're dealing with prime numbers, okay, which already can't be divided by themselves, and because of the square root, it's probably irrational as well. So we have x is equal to 7 plus the square root of 13 on 2, or 7 take the square root of 13 on 2. So here we have two rational roots that can be, two real roots that can be calculated, okay? And what that means is on the function, okay, that 7 take the root of 13, that might be that point there, and 7 plus the square root of 13, that might be that point there, okay, when the function crosses the x-axis. So this is just an introduction to the discriminant. It should be a fairly easy concept because it just expands on your knowledge of the quadratic formula, and it's just important that you're aware of this information. So not necessarily expect to remember it, but have it in front of you.